had a few people that wanted me to go over custom grips. It's been a request for a while, and well, it's about time I actually did it. Oh, I better take off. 1 second. I'm gonna take off push to talk. Okay. Yeah, I'll up my mic volume. Hey, that's a little higher. That should be good. Okay. I realized it was hard to hold push to talk while I was trying to mess with the editor. So custom grips are the option that I added to the plugin so that when you run into something that you can't do with the standard grip options, you can still implement it separately, because I can't actually cover every single option and thing that you can do with gripping or interacting with objects in VR. It's pretty much unlimited what you can do, so there's no way I could cover it. And also, I wanted to be able to support like marketplace packs and things like that that do the standard logic of the Epic interface, and you can do that with custom grips. So I mocked up this tutorial slider. That's actually uses all of the advanced logic, so I'm not going to go over that first. First, I'm going to go over a new one. So I'll just make a grippable static mesh component. Yeah, it could be an actor too. This is just going to be custom grip. Okay, so the way custom grip works is it's a method of doing attachment-like operations, but still have all the multiplayer and replication of the plugin work with it, and without you having to do special logic for this is a grip that's outside of the plugin's normal grip capabilities. So literally all you have to do is you create a grippable like this, and you go into the grip settings and you change the grip type to custom grip. And if you want to be really sure and just don't mess with anything, you can override via grip information, get primary grip type. You can implement that function and always return a custom grip. So if you were to implement the interface manually instead of using a grippable, like you had an object that already was set up and it wasn't a grippable base, then you could add the interface in and then override these interface nodes. Now, all of the normal interactables in the engine, in the plugin, like these levers and this dial and slider, they all use completely custom non-grippable components, and that's so I can save on overhead and keep them as light as possible. In Blueprint, if I was making a new interactable, I probably wouldn't do that because it takes up a lot more time to go into all of the interface functions and implement them and make sure that they're correct. So if you're just doing a normal grippable, it's easy enough just to take a grippable component and set its properties. Now, generally with custom grips, simulate and drop is up to what you're doing. If you're making an interactable component, obviously most of those don't simulate on drop, so I'm just going to take that off for now. Force client-side movement standard. That means all the clients move it on their own. Late updates always off is fine. The one thing you want to worry about is constraint break distance. You probably want to set that up a little higher, because on custom grips, you're controlling all the logic yourself. The motion controllers are no longer telling the grip how to behave or when to drop. So you have to make sure that if you want auto drop, you need to mess with this variable manually, and I'll go over that later. The basics of custom grip is you still have event on grip for when gripped, and you get your controller and grip information. You have event on grip release for when your grip is released, and then you have a new one which you don't normally use, which is event tick grip. And this is a replacement for event tick. With custom grippables or custom gripped objects, you don't need to use event tick. Event tick is, you can still use it for other operations, but for the movement, I'd prefer you use event tick grip. This is called directly after the motion controller itself ticks, So you have the very latest motion controller location and all up-to-date variables. So event tick grip, event on grip, you've been gripped, you've been released, and this is frame by frame information about you. So the very simplest way to do a custom grip is to say event on grip, gripping controller, and you could do a self, and you could do attach to component, and you could attach that component. And there, you essentially have Epic's gripping system. You attached to the motion controller on grip. To do this correctly over a network, obviously you would want to base it off of the grip information. This grip information has additional stuff like relative transform, which is where you're supposed to be relative to the motion controller. So you'd be covering that, but I'll go over that in the advanced one. So on grip, you've successfully attached yourself to the component. On grip release, you would detach from component, and I'm gonna snap to target on grip, just because I think that's default behavior on them. I'm gonna keep world on release, and event tick grip does nothing in this case. So if we were to take, should have made an actor for this. I'll just add it onto this. If we were to take the slider and add a custom grip to it, static mesh 1 cube 0.1, 0.05, 0.05. And now we have a little custom grip node there. So now when we go in and we walk up to this, we attach it to I attach it at relative scale, so that's a huge ass object, which is why I did that. So that's snapping to controller, and if you wanted it to not snap to controller, you can take grip information, break it, and you have relative transform. And this is the transform relative to the motion controller that you want it to sit at. So you would just move it to that location and then attach, or attach to it and then set relative location to this. So actually we should be able to just, I believe it should work with just set relative transform. This is a quantized transform, but I have conversion nodes set up for it. Just keep world location and then set relative transform. Yeah, and now it's attached at correct scale to the hand, just like Epic setup. And you can drop it and let go. And it's a custom grip. None of my default plugin grips use attachment for several reasons. One of them being you can easily do this if you wanted to. Alright, so that's the basic of that. Next up would be if you want to actually use event tick grip and you wanted to do something on grip. So let's say on grip release, and event tick grip, you're going to break that same grip information, and you're going to self, and you're going to set world location to motion controller get world transform. Compose transforms and relative transform. Actually, I should set world transform. Alright. So this one, instead of attaching, just moves the component to the correct location relative to the controller on every tick. And that's all just information that's stored in the gripping structure. So you should pick it up and you're walking around with it. And see how this one delays behind a little bit? In 2D, tick order is a little off. In VR, that wouldn't be there. But this one's moving on tick, so you can do things like enable sweep on it. And you can go pick it up, and then it won't pass through objects anymore, because now it's sweeping. So there you have a custom swept grip. I mean, and that's the very basic of the custom grips. I mean, if you wanted to do auto drop by distance, let me switch over to the more complicated one. I'll save that. Go over to here to tutorial slider. So we'll add a tutorial slider into here. Okay. Oh, that's up. Okay, so the tutorial slider is something that I made that actually implements some of the more complicated parts of the ability to use these and implements an interactable. It basically makes a very basic slider component. So first of all, this was just that set location on grip spot, which I just showed you. Nothing big there. I'm just leaving it in here as a reference because I'm going to keep this tutorial slider as part of the content of the template. I went in and decided to make a utility library for interactable components like levers and stuff like that for people to make the complex operations easier to use. And that's in the plugin as of today. So these functions right here are now exist. They didn't before. So they used base interactable data, which stores a bunch of information that interactables commonly need. I'm gonna have to go over this in detail. The way most interactable items in VR are done, at least in UE4 that I found, was they'll either make an actor with subcomponents, or they'll make two components. One is a root and then one is a child, and they'll move the child. And I never really liked the concept of a complete actor for, you know, like a lever, or two components for a lever to make it work correctly in relative space. It always seemed messy. So to get around it, what I did was I made all of my interactable components record their initial transform relative to their parent on begin play. And then they take that transform and they save it and they use it as its like a static, I've been calling it a static space transform. And that's how it offsets all of its movement relative to there. So like, well, the slider. The slider starts off, this will be easier. The slider starts off in this position in relative space to its parent. So on begin play, it records that and saves that it's, you know, right here. And then when you grip it, it records your hand location relative to the slider, and then the change in your hand location relative to the original static space that it was in. So it saves this transform and the difference in your hand from that transform to move the component. That way when you move the component, it's not changing the component's transform and screwing up you trying to do this. Because normally when you would translate that component there, it would change its relative transform, and you would no longer know, you know, where the hand is relative to where it started off being. You'd have to add math. So this works out a clean way of doing that. So for the tutorial slider, I have generate our static space information. It on begin play, you call this interactable begin play init, and it'll fill in initial relative transform, which is the static space. And then on grip, you do interactable on grip init, which fills in the rest of the information. It fills in initial interactor locations, your hand position relative to the object. It fills in initial grip location, which is, let's see, yeah, that's for this. That's your the hand position relative to the static space. And then initial drop location is your hand position relative to the component itself. And that's useful because you want to know how far your hand moves away from its point on the component for when you want to auto drop it. So this is hand location, this is initial grip location, and this is initial drop location. So grip lock is you relative to the object, this is interactor is you relative to the space. Reversed relative transform is how I get around multiplayer having issues. I didn't want to send additional information for multiplayer, so I'm reversing the transform of the held objects relative to the controller, which makes the transform then relative to the object. So you have the controller's position, and that's what lets me get the initial grip lock and initial interactor locations. You don't really need to worry about all this. This is just, the advanced stuff to get this all working cleanly with a single component. But I have these utility functions here to auto-calculate it for you. So, with those initialized, then I go into event tick grip, and first I check for drop, which I was going to make a function, but it was too many inputs, so I just left it up to here. So in check for drop, we get has grip authority, which if we're a client authoritative grip, will be always true if we're a client. If it's a client-side movement, then you have to be on the server to have grip authority. So this is just a filter to make sure that you have the ability to drop it or not. Otherwise, we don't even check for drop. So if we have the grip authority, generally the server true, we get the grip break distance of this component, and then we get the our world transform in the motion controller. So we convert the motion controller into relative space, and then we subtract that from the initial drop location to get the distance. So now we know the relative space distance of the hand from where it started at, and then we just compare to see if we should drop it or not. If you don't want auto drop, you can just skip this step entirely, or you can raise the auto drop distance to something huge. So if it is larger than the vector length squared, then it'll say you should drop it, otherwise it'll say you shouldn't drop it. If check for drop is true, then we'll drop object by interface. Because we have grip authority, we're allowed to do it. So then the object's dropped and we cancel out. Event on grip release will be called and the object's no longer held. If it is not dropped, then we go into the slider logic. And normal slider logic would be really simple. You just record the hand's position and you move it along with it. But since this is for multiplayer and I'm doing this with the singular component, it gets more complicated. So we have the initial relative transform, which is our static space, and all the other base data variables here. Under self, we can get interactable get current relative transform, and this will get our current relative transform to our parent. So it'll take this initial relative transform, times it by our parent's transform, and get our current location. Because with normal objects, our relative transform is updated every frame, right? But with this, since we're saving a static space transform, it's not, and we don't need to update it until we need it. So this is just the initial relative, and then when we combine it with the parent, we get the new world space. So we get our current relative transform to our parent, and then we inverse transform the world location of the motion controller to get the relative location of the hand in this current frame. And we take the initial interactor location, which is the hand's initial location on grip, and we subtract that from it. So now we have the difference that the hand is moved. Yeah, Gark, I'm recording. I have the difference that the hand has moved since you gripped it. This vector here. So let's say you've moved 50 units. So I can add that 50 units to the initial grip location, and we have the new location where we want to set the slider. Then I clamp it. This is just some clamping math. You don't really need to worry about it unless you go into it. I'm just clamping on x-axis. It's a little messy in blueprints. It's easier in C++. And then since this is all in relative space, I then transform this relative static space location back into a real relative transform, and then set relative location. So what that means is you have a fully functional slider with a custom grip that's limited to +100 on x-axis and follows along with the hand. and it has auto drop. So if you go 100 units away, it'll automatically drop it. And no matter where you pick it up, it'll remember where you pick it up at and retain that initial position because of the initial grip location. So initial grip location is how you know the offset to keep the relative location at. And like I said, this is a complex interactable because I wanted it to be fully multiplayer for this, and because I'm doing clamping and I'm working with the singular component transforms. And like I said, the whole reason for that is so that I don't have to do this logic in the actor. I can do all the logic in the component itself, and then I just drop this tutorial slider in this actor, no setup, and go into the level and it works. It remembers where it should be. The reason why we're recalculating the get current relative transform when we're doing this is because the parent may have moved. So we want to make sure that when we convert the motion controller into relative space, that we have the correct parent transform too. So, I mean, that's a basic slider right there. Non-interfaced interactables, I already went over attachment grip, so screw that. Non-interfaced interactables are like all of the C++ ones. Like I said, they're all done without the interface, without it being a grippable. And the interface is manually implemented, so I skip everything that they don't need, and they're lighter weight. But you don't have to worry about that for Blueprint. You can just literally make a grippable component and set it up as an interactable. Secondary custom grips. Now this one's interesting. It's a new addition. If you go into your grip interface settings and you go to secondary grip type, you can set it to custom as well. Yeah, an event on secondary grip will be called when you grip it with the second hand, but it won't do anything. This won't rotate the object to face the other hand. It won't deal with any logic. It leaves it up to you now because it's a custom secondary grip. So you could take this original logic here with the slider, and when your other hand hits it, rotate the slider to face the other hand or offset it to in between the hands so it slides to the central point between them, or whatever you want to do. So this gives more flexibility for two-handed interactions. And I realize a lot of this might not be entirely clear and easy to grasp. You don't have to do any of it. You could literally just do a normal custom grip and your own logic. But this is specifically because I wanted to make it so that components don't need parents and they don't need anything else, and they can just work in if you drop them into an actor. If you wanted to do all this logic normally, you could put a sync component as the root for this thing, and it would work, and you could just screw all this relative transform shit and just, you know, set world location or set relative location. This is just a foolproof multiplayer method of doing it. And the multiplayer method comes into the initial relative transform and the reversed relative transform. I know people can have questions on this. I'll talk it over later. Like I said, the basic is just tick grip. Yeah, to rotate, Victor, rotating's easy as well. I didn't put into this because I made a slider. But to rotate, you go up here, and after the event on grip, you store the controller's rotation. And then when you go down here, you take the controller's rotation now minus the old rotation, and or location even. I mean, you can do the you can get the I forget what it's called. I have it somewhere here. I'm sick. Testing lever actor. Here we go. Where's my get angle? There we go. Oh, the angle. That's not actually correct. Whatever. Anyways, you can get the you can get the hand's rotation around the component, and then get the difference in its rotation around the component, and then rotate it. And that's another reason for the initial relative transform, this static space, is while you're rotating the thing, you know the hand's location compared to its original location, and so you can get the rotation right. But you can just switch this logic up from sliding to rotating when it's at a certain spot, and then back to sliding again, or however you want to do the logic. It really doesn't matter. I mean, you have full control over movements with this. That's why it's a custom grip. It's a little hard with normal grips to take like an addition transform and try to get the stuff out of it that you want, which is why this was created. I guess that's pretty much it for custom grips. I mean, I don't give you that much with them because it's made to be custom implementations. I'm just doing this utility library, which is useful. It's under Interactable. Interactable in the blueprints. So we have begin play initialization, we have on grip initialization. Check should auto drop may go away because there's a lot of inputs on it and it looked really messy, which is why I left the check for drop down here and implemented it. Get current parent transform, you can use if you want to get the current parent transform. So what this does, if it checks if you are attached to something, like your subcomponent in an actor, then it'll return the parent's transform. But if you're the root component in an actor, it'll return 0 transform. And that's why all the interactables can actually be a root component in an actor, or they can be a subcomponent in an actor, and it doesn't matter. They'll still behave exactly the same. And then we had the interactable get current relative transform, which is how we get the current relative transform to the parent. And do the slider logic. So most people will not care about any of this. A lot of this is for advanced multiplayer play or truly generic interactables. Most people will be doing something like that simple slider that I made. Testing interactable tutorial slider, where it's just like, you know, oops, that's the wrong one. Custom grip, where you're just attaching or setting world transform and altering how it works. And you could do literally any kind of grip you want with this. All of the VR button, VR dial, lever, the mount that Space Harry made, which I appreciate, and the slider are all done using a custom grip and all the same math that I showed off in that tutorial slider. So the fact that they work so well is because I specifically put in all that logic. But none of them are with a normal grip, and none of them require that much complex math. It's just, you know, custom grip with getting locations on hands and stuff. So I hope people understood at least a part of this. And the tutorial slider is now in the template under 4.18. I'll merge into 4.19 sometime. Not a big deal. It's 4.19, still unstable. And people can just play with it. And I don't know. I guess that's it. I gotta go make dinner. So enjoy.